Okay, I think people can see that now. So yes, thanks for the introduction. I'm Jon Gibbons. I'm a mechanical engineer by profession, working at a university, as it says here, and I've been working on carbon capture and storage for about 20 years. So I'm, as well as working at University of Sheffield, I'm director of something called the UK CCS Research Centre, which is open to anybody who wants to, has a legitimate interest in CCS, or even illegitimate, I guess. It's free to sign up to newsletters. It's free to attend meetings. So if you are interested in carbon capture and storage, go onto the website and see about signing up as an associate member. And I'm going to tell you a little bit about CCS, but we did a series of 18 lectures, mainly for civil servants initially, on CCS related topics, and you can look at the lectures for those, lecture notes, and also hear recordings of them. So there's lots of information there. So I'm not a climate scientist, but I know some people who are, particularly a guy called Miles Allen. And Miles Allen, climate scientist at University of Oxford, has basically worked quite a lot on getting the realization that it's cumulative CO2 emissions that matter for warming accepted. So we're basically putting carbon dioxide into the atmosphere. Some of it then very quickly dissolves in the surface layers of the ocean and doesn't really go anywhere after that. In fact, it will come out again if we had a reducing atmospheric CO2 concentration, because it's driven by the equilibrium. And you can see my mouse, the ultimate level of warming. Can you see my mouse? Wait, please. Yeah, good. The ultimate level of warming, which is the vertical axis, is a function of the cumulative CO2 emissions. And these are as gigatons, billions, excuse me, billions of tons of carbon multiplied by about 2 and a bit, yeah, 3 and a bit rather, to get the amount of CO2. So we can see we've got about, in his, for 2 degrees, about 1,000 billion or 1 trillion tons of carbon, rather less if we want 1.5 degrees. So that's the nature of the problem. We've been putting carbon dioxide into the atmosphere. You can see really most of it's gone in the last 70 odd years, post Second World War. Obviously we're further on now. And the nature of the things is, if we stopped emitting CO2, the climate would carry on warming because of the lag, and the CO2 itself will come out the atmosphere very, very slowly. Basically, the immediate mechanism is vertical mixing in the ocean. The ocean can hold a lot of CO2. If we look here, this is showing where the carbon is. So pre-industrial atmosphere, and then the surface layers of the ocean about as much. The deep ocean holds lots of CO2, but it's locked off from the surface layers because the surface layers are warmer and don't sink. And then this is the fossil carbon we've added. And these are the reserves of fossil fuel that we could add. The reserves are just really what people basically can count as assets on balance sheets. So the actual availability of all fossil fuels is enormous compared to the remaining space in the atmosphere. A bit of land use, it could go up significantly if we get warming and release of carbon dioxide from peat. You can see over here the biosphere, soils and vegetation, and permafrost, forests within the soils and vegetation. So reasonably large, but not that large in a sense, compared to the atmosphere and fossil, and certainly forests compared to fossil additions to the atmosphere, roughly comparable, to get it all in perspective. And then the sort of pink area is what's in the the Earth's upper mantle. These are the rocks, just absolutely enormous amounts of carbon dioxide, mostly as carbonates. So Miles Allen pointed out that a sufficient and probably a necessary way to avoid dangerous climate change is if you're using fossil carbon or extracting fossil carbon from the rocks, the geosphere, then if you're doing that, you should put it back again. And the fraction of the extracted carbon that you need to put back has to reach 100% by the time you've reached the limit of carbon that you want to put in the atmosphere. So along the bottom here, this is something he did in 2009, was the amount of carbon going into the atmosphere. At that point, we'd got 600, we're close to 700 now. And the amount of captured, which at the moment is essentially zero, but then, and you don't have to have a straight line here, but by the time you get to the trillion tons limit, you want to be capturing 100% of the carbon you take out. Now, there's no particular idea of you taking out any amount. It doesn't really matter what the rate of carbon extraction from the geosphere, which might be fossil fuels, but it could also be limestone for cement. You don't have to do it. You don't even have to do any, although the expectation is you'll be doing some, but it's just logically the case that if you don't want to add to the carbon dioxide in the atmosphere and the surface layers of the ocean, after that point, you've got to be putting exactly the same amount back. And that's really what's there. And as I say, that is a sufficient course of action to avoid dangerous climate change. And to the extent that it seems very unlikely that we'll move from the present 80% of energy, roughly, coming from fossil fuels to zero in the very few decades that we're going to have to sort out climate change, then it's probably also necessary. I'm not sure we're going to get to 100% capture in a few decades either, but that's another story. We'll get onto that a bit later. Just looking at it another way, this is showing where the tons of carbon emissions per year are coming from. This only goes up to about 2014 because the data was stopped being collected after that due to change in the US administration. But anyway, we've got coal, oil, natural gas, and cement as sources. And just as I say, you can see really how everything has happened since the Second World War. And indeed, big population increase in parallel, and also quite a big increase in living standards too over that period. One of the things I put on here, particularly for oil use, I think you're going to have to recapture that CO2 from the air. Most of the useful applications for oil involve transport. And if you're using oil, you'll probably want to keep on using it for transport. You don't want to try and capture the CO2 at the point where you're using it. So you'll recapture it from the air. I'll say a bit more of that. So carbon capture and storage, there's essentially three parts to it. There's CO2 sources, which can be industry, hydrogen production from fossil fuels, biomass, or taking it directly from the air because there's 400 odd parts per million of CO2 in the air everywhere. So you capture it, you transport it to somewhere where you can put it into permanent storage, and permanent's very important. And that can be either as a pipeline compressed into a dense liquid, or shipping it as liquid, or taking it by rail in tankers, chilled and a little bit compressed. And then you store it. And the place you store it, for doing nothing, put it into a saline aquifer. That's porous rocks deep underground. They've got water in them at the moment. And you put some CO2 in the place of the water. It'll dissolve over time. You can put it in hydrocarbon reservoirs, oil reservoirs, gas reservoirs. This may get out some more, particularly oil, It's not really a problem in a sense. There's plenty of oil being produced, so I wouldn't worry about oil from enhanced oil recovery. We've got to solve that problem by other means, I think. And then there's permanent, I say permanent use. That's if you're locking it up, for example, in building materials, that's a permanent storage. But permanent's got to be a long time, as we'll see. So, excuse me. If you're looking at the climate, you want to store carbon permanently for 10,000 years. That's about the time for mixing the CO2 in the ocean. So 10,000 years is a pretty good metric. This is contrasting storing in the lithosphere, in the rocks, which is essentially permanent. We know we can store liquids, gases underground for very long periods in the right places because we've got the fossil fuels, gases and oil there. And so this is something done by a colleague of mine, really, Stuart Hazeldine at Edinburgh, saying 120 pounds per tonne. If you go into biosphere carbon, then your storage might be up of the order of 100 years. And although it's cheaper, you're going to have to keep on redoing it to get the permanence. So you can end up with a much higher cost effectively. And very, very, I think people looking at essentially carbon removals, carbon dioxide removals, are starting to think quite seriously about permanence. And indeed, we really do need to. So CO2 storage, what it looks like. This is a project that's been running since 1996, not so far from here, in the North Sea, off the coast of Norway. I think I've got a map that roughly shows where it is. And this is taking carbon dioxide that's separated from natural gas and has to be taken out anyway to put the gas into the gas system. And to avoid quite a large carbon tax on offshore installations in Norway, it's injected into a very porous sand layer underneath, about 900 meters down. This is showing it to scale. So you can see it's quite deep. You've got to be deep, otherwise the pressure isn't high enough to make the carbon dioxide dense. It's about at least half the density of water at this point, not a gas really. The nature of the storage here, you've got essentially an old valley that's been filled up with sand. It's not even very, very strongly compacted. If you imagine a beach and the water going on a beach as the tide comes in or the waves come in, you see a wave come in, some of it runs back, but a lot of it just sinks into the sand because it's so porous. And that's what's happening here with the carbon dioxide as it goes in through a well at the bottom. It passes through the pores between the sand. It actually floats up to the top where there's an impermeable layer that stops it, and then it spreads out. I don't think I've got any more pictures of that. So that's an example of storage. Quite often it's deeper than this. This is about the shallowest you could actually go and still have dense CO2. So that's storing. Capturing CO2, this is an example. This is the first large capture unit in the world. It's on a power plant near the Canadian-US border in Saskatchewan, which is it's the second one over. No, third one over from the left in Canada. So, excuse me, there's a coal-fired power plant. From the bottom of this chimney here, there's this big duct going across, goes behind the plant, taking the flue gases that would have come out the top, which contain about 12% CO2, and they're going into a column here, which is a big tall column, and you get some idea of the scale of these from the cars. They're about 80 meters tall, I think. It goes into a unit here that washes the sulfur out, and then it comes down to the bottom again, and it goes into a larger unit here that washes out the carbon dioxide, and then the gas without the CO2, and it comes out this little chimney at the top. The way that the carbon dioxide is washed out is use a chemical mixture that captures CO2 when it's cold. It reacts with the CO2 reversibly when it's cold, so 30, 40 degrees centigrade. It's then taken away, pumped away, and trickled through corrugated packing in the stripper column here. And at the bottom, it's boiled. And the steam from the boiling rises up and heats the falling liquid. And the nature of the chemicals is that when they get hot, so up to about 120 centigrade, they release the CO2. And you end up with a mixture of carbon dioxide and steam at the top. You can condense the steam into water, and then you're left with carbon dioxide, which is compressed in like a big vacuum cleaner compressor, really, centrifugal compressor, in this place here, and then sent away for storage. And this site can store CO2 in an aquifer, quite deep actually, right at the bottom of the sedimentary rocks in the Saskatchewan Basin, about 3 kilometers down more. Or it can go for enhanced oil recovery in the local oil fields. Another capture project. This is on a cement plant in the south of Norway. This is just being built. This is taking the gas from the cement kiln, which contains both carbon dioxide from the fuel that's being burnt and also carbon dioxide from the limestone that's used to make the cement. And about 2/3 of the carbon dioxide when you make cement comes from the limestone. This is where they're washing out the CO2 from the gases. Taller stack here to take you up to the normal stack level. This is where they're being released. And then they're going across to a ship, because this unit doesn't have a pipeline, it's on the coast, relatively small amount of CO2, about 500,000 tons a year. And so they're being shipped to a storage site that Norway's setting up on the west coast. This is showing the ship coming in. This site has a pipeline going, I think, about 50 kilometers offshore to storage, similar to the Schleipner one that I showed you. And this terminal, actually, there's some CO2 storage here to store the CO2 when they're unloading the ships to keep the flow in the pipeline steady. This terminal is able to take carbon dioxide from all over Europe, and Sweden is looking at sending CO2 there, and sites in Germany, Netherlands, maybe even some in the UK. And they're due to get the first shipments around 2024, 2025. The UK is planning something similar at a number of sites. I'll probably show you. Just CO2 capture. This is a unit at Sheffield, close to us. So this is actually looking at capturing a ton a day of carbon dioxide for research purposes. But one of the things we're doing here is actually looking at how you can capture up to all of the fossil carbon in the flue gas, which is very important for net zero. So this is where I spend a fair bit of time looking at how you would improve the technology. So, although CCS has been around for a long time, and although arguably capturing and storing carbon dioxide is pretty important, it gets really to the very core of the climate change problem. Surprisingly, neither fossil fuels nor indeed carbon capture and storage have got a lot of mention explicitly in the COP process. And I have to say, you rather wonder just how serious people are if they can't get around to actually talking about it. So COP26 was the first mention of fossil fuels and CCS, and the final text of the Glasgow Agreement had this clause 20, which talked about accelerating the development, deployment, and dissemination of technologies and adoption of policies to transition towards low emission energy systems, included by rapidly scaling up the deployment of clean power generation and energy efficiency, and then including accelerating efforts towards the phase down of unabated coal. Now, unabated in this context means coal use without carbon capture and storage, and the phase out of inefficient fossil fuel subsidies. I'm not quite sure what the definition of inefficient fossil fuel subsidy is. while providing targeted support to the poorest and most vulnerable in line with national circumstances, and recognizing the need for support towards a just transition. And this is, I'm told, the first mention of a fossil fuel in a COP communique, and the first oblique mention of CCS as well. COP27 tried to, a communique from that implementation plan tried to talk more about all fossil fuels. India brought that in, but all fossil fuels didn't get there. And I think Saudi Arabia tried to talk about carbon capture and storage, and that didn't get in. So the compromise was basically do nothing. Although I think something I'm fairly happy about is the clause here that they call upon all parties to accelerate technologies and policies, but then include the transition towards low emission energy systems. And I think that's important because people want 24/7 energy. They want energy for different purposes, and it's energy systems really that deliver that. And then they quoted the same thing about phase down of unabated coal and phase out of subsidies. But as I say, there's a LinkedIn article you could find if you want to read more. The thing is actually getting things to happen. It's all very well to talk about this, but talking won't cut CO2, and all the atmosphere cares about, all the climate cares about, is cutting CO2 emissions. So going back to the climate science and also talking a bit about what phase down might look like. The IPCC report on 1.5 degrees basically has to face up to the fact we need to limit cumulative emissions. So we're somewhere over here at a very high level of CO2 emissions per year. And to limit cumulative emissions to the level where you might have a reasonable chance of limiting temperatures to 1.5 degrees, you would have to drop emissions very rapidly. And in most circumstances, unless you drop them extremely rapidly, you've overshot the budget. And if you've overshot the budget, the only thing you can do, well, with CO2, is you can pull some CO2 out the atmosphere. And as you can see, just about every scenario includes periods of negative emissions after 2050 and quite large periods, quite extended periods of negative emissions after 2050. And there's a lot of talk about, oh, we need to get to net zero. Yeah, okay. But unless you get to net zero much sooner than we're thinking of doing, you will not be able to achieve 1.5 degrees. So that's the, well, without going negative for an extended period. So that's the, if you like, the reality of it. Obviously, we're looking at quite large reductions by 2030 if we're on that path. But 2030 is extremely soon. So one of the things that's happening, as I say, people are talking about phasing down rather than phasing out. This is quite important, I think. I don't think it's reasonable to tell countries like India and China to phase out coal, because we've phased out coal in the UK, but we've just substituted natural gas for that. And we're getting quite a lot of problems as a result. We nearly had quite a significant coal fleet, about a dozen major coal-fired power plants with carbon capture and storage. Those are nearly built in the 2000s. If we'd had them and we're using them, obviously we would have saved electricity consumers quite a bit of money, and would have actually had lower CO2 emissions. Anyway, this is a 2016 number of coal plants, about 2,000 gigawatts. That's something of the order of 3,000 probably, given the average size coal-fired power plants globally. And a phase down situation might see about half of those closed, but about 10% of them fitted with carbon capture and storage. And the other half, they're not running very much. So this is the fraction of their capacity they run at the moment. The world coal fleet on average runs about 50% of the time. It's not always needed to meet demand. And increasingly, when the wind's blowing, and the sun's shining, you've got other sources which you'd rather use. So the idea that in the future that will go down to about 10%, the load factor on plants with CCS will be somewhat higher. So the consequence for CO2 emissions at the moment, emitting of the order of 10 billion tons a year, so about a quarter of global emissions. And that will go down to rather less than 1 if you phase it down. And I think that's a pretty reasonable state to expect countries like India and China to be in, where they're using a lot of renewables, but they actually also have some plants that will reliably give power when it's required. And it really doesn't matter what you do, how you produce the CO2. What matters is the amount of CO2 that goes in the atmosphere. And to be honest, it makes me pretty disgusted to have Western countries with very high per capita CO2 emissions relative to places like India, but coming from oil and gas, saying that Indians can't access coal to provide the basic necessities of life just because it's coal. It's just, there's no climate justification in that. So I talked a bit about capturing CO2 from essentially chimneys on places that are using fossil fuel, but if you want to get to net zero, you'll have some emissions from places that can't be captured that way. And if you want to get 1.5 degrees, you will have to pull CO2 out of the air. And there's basically 2 ways of doing that with permanent storage. One of them is BECCS, biomass energy with carbon capture and storage. You've got carbon dioxide coming from the air into vegetation. The vegetation's burnt. The flue gas goes to a capture unit, very similar to the ones I've been talking about. You could use it to make something carbon neutral, but that won't give you net negative. So you would typically store it deep underground, and that will give you negative emissions. But there's not that much biomass around. And if you're trying to get food production, obviously you worry about producing biomass as well. There's some amount in refuse, energy from waste plants, not a great problem. Nobody worries too much about capturing the CO2 from biogenic material in wastes, but there's a limited amount. So if you want something that can remove CO2 from the air in essentially whatever quantity you want, and it's just a matter of paying money, then you need to take CO2 from ambient air. And you can wash it out using chemicals. You can react it with lime. You take limestone, cook the CO2 out, and then it will pick the CO2 up again. That's a process we get in buildings all the time. Or you could possibly freeze the air and take it out that way. Any which way, you still want to get permanent storage and then put carbon dioxide deep underground and keep it there for tens of thousands of years. And one of the characteristics of direct air capture is that you can do it anywhere in the world. The atmosphere mixes the carbon dioxide very well. So you can pick the place where you can get storage, you can get energy to drive it, you can get space to build the plants. And it's just a matter of money. Now, something I'm going to add, which is not carbon capture and storage, is I think technology that's very likely to be suggested given the way things are going, and quite likely to be implemented. So if you look at the figure here, first of all, this is a cartoon of global mean temperature as a function of time, and under a number of emission scenarios. So one is no policy, renewables come in slowly but don't really cut CO2 emissions that fast, get quite a high temperature rise. The blue one is what we might get if we cut emissions to zero. But as I say, the amount of CO2 in the atmosphere doesn't go down, and we still carry on warming and only come out of the warming phase relatively slowly. And so we will get a temperature rise probably above 2 degrees where we're at now. Another scenario is that we cut emissions to zero and then remove CO2 from the atmosphere. So we will eventually then get down to at least 1.5 degrees and eventually lower. But there will be an overshoot. And in that overshoot, we could get very serious impacts from climate change. We could also, even more worryingly, get irreversibilities, such as releasing methane from permafrost, which, if you do that, then you basically lose control of the climate. It's a positive feedback. It makes it warmer, and if it gets warmer, you release more methane. So the suggestion is to get a rapid result. You mimic essentially what's happened with large volcanoes, where you get stratospheric aerosol emissions. And these, as we know from a number of examples in the past, will reduce average temperatures. They don't reverse climate change. They may reverse some of the effects or mask some of the effects. They may buy time. They add a lot of risks. The principal thing is that doing this is relatively cheap, and most importantly of all, it's quick. There's no way, however quickly we're able to pull CO2 out of the atmosphere, realistically, that we can afford to do it rapidly enough to slow climate change down very fast. So there's a reference there. You can have a look at it. What if it causes famines? Well, I don't think the expectation is that it would cause famines. We did get effects when we had very short growing seasons in the 1815, the year without a summer. But I mean, the intention is, if you use this, it wouldn't be the year without a summer, as we saw, I think, after Krakatoa went. It will be the year without a dangerous heat wave. Certainly the intention. Will it actually work that well? I don't know, but I'm just saying, if you start to see people being killed in large numbers by extreme weather events, particularly high temperatures, or you start to see irreversible things happening, particularly things which will give warming, or even the Greenland ice cap being destabilized, you will see people saying, what about stopping it using solar radiation management? Okay, just a bit more about direct air capture. Just some examples. This is a plant in Saskatchewan. In British Columbia at Squamish. It's a modified cooling tower, and this is using potassium hydroxide solution, very alkali solution, to react with CO2 in the air. It's then regenerated against calcium carbonate, limestone, heated by natural gas. And this overall configuration burns natural gas and captures the CO2 from it, and then uses the heat from that to capture, for every molecule of natural gas, carbon dioxide, another 2 molecules of CO2 from the air. Personally, I think using fossil fuel to capture CO2 from the air and storing the CO2 is quite a good thing, because, if you like, fossil fuels are the threat to the climate. And if they're sterilized, put out of the way, stored as CO2, they're no longer a threat. This is a unit that's being built in Texas by Oxy Petroleum. They're going to use the CO2 to produce oil, and they're selling the oil in California as low carbon fuel because of the amount of CO2 that they're taking from the air while they're producing it. And that will pay for the plant. The Chief Executive Officer of Oxy, Vicky Holub, is talking about having 100 such plants operational by 2035. If this one's successful, I really hope it is. It'll make a huge impact. And this is capturing, I think, not quite as much as 1 million tons a year, but somewhere between 500,000 and 1 million tons. A unit that's around, relatively easy to build, made by Climeworks in Switzerland. And this is a much smaller unit, as you can see, and it basically has a porous bed inside which attracts CO2 when it's cool and releases it when it's warm. And you cycle between cool and warm, and this will capture a few tons of CO2 per year from each one. It's used in greenhouses, used for demonstrations. They built a unit in Iceland where they're taking 4,000 tons of CO2 per year from the atmosphere in these banks here, and then it's going underground with the liquids from this geothermal power station over here, which is also providing the heat to release the CO2. And then it reacts with the volcanic rocks that are around. They're very reactive to CO2. Oh, this is just something I'm doing, which is, it's not very well presented, but it's basically looking at combining taking CO2 from the air with taking CO2 from a chimney. And if you do that, you may be able to get lower energy. That's a bit scientific. So just to sort of give a simple view of it all, net zero hydrocarbons, basically you've got carbon dioxide removal from the air at the center. And people are talking about two different things. I've been talking, I guess, explicitly about producing fossil fuel, putting the CO2 in the atmosphere, gets mixed, it's taken to a carbon dioxide removal system, either direct air capture or biomass energy with carbon capture, and then it's stored permanently. And so you've got this circuit here. It comes out of the rocks, it goes back to the rocks. There's also other circuits that people talk about using, where, if you like, you start taking CO2 from the air, you react it with hydrogen that's made from water by electrolysis, make a synthetic hydrocarbon, and then you burn that, and CO2 goes back in there, and that's another circuit which is also net zero. You will inevitably have some emissions from materials you use and things like that, so you will need a small amount still of storage with that. But these get absolutely equivalent effects. As I say, I quite like producing fossil fuels and putting the CO2 back underground, because if you just say, oh, I didn't use the fossil fuel, it's there in the ground, it also has to stop in the ground for 10,000 years. And I actually don't know a way that you can stop people using fossil fuel if it's there. You can buy it, you can own it, you can do all sorts of things, but basically you can't stop people. Whereas if it's underground, there's CO2, it's sterilized. Excuse me. So just to summarize, cumulative emissions of CO2 are the main factor in temperature rise. It's likely that the cumulative emissions will exceed the amount for 1.5 degrees before we reach net zero. So there'll have to be a period of net negative emissions just to get things back on a level keel. We may want to do some solar radiation management, essentially to buy time for the negative emissions to take effect. And indeed, if you can't give people some hope that they can actually get on top of the problem, then they won't ultimately bother pulling CO2 out the air. If you're pulling CO2 out the air, but as fast as that, you've got permafrost releasing methane and peat drying out and oxidizing, you're on a hiding to nowhere. CCS covers a lot of technologies, but they've always got the same basic purpose, which is to put fossil carbon back underground permanently. And permanent means more than 10,000 years. You can produce carbon-free energy vectors with CCS, and that's electricity, hydrogen, or heat, or indeed ammonia, which you can use as a fuel or industrial products. And you can also remove CO2 from the atmosphere. I think carbon dioxide removal, when the emitter pays, is very reasonable. If people want to do things and they're prepared to end up with net zero CO2 emissions to the atmosphere, that seems a very reasonable option for people to have. However, the alternative, which is not recapturing your own CO2 if you put it in the air, but leaving it to others in the future, is intrinsically unfair. And carbon dioxide removal from the air can either be viewed as a very, very, very good thing, and I think is transformative in the sense that you then put the onus on people to clear up the mess they've made, and you give them a way to do that, which we don't have at the moment. But also, if people said, oh, well, I won't bother, I'll just leave it to people in the future, they'll be able to do carbon dioxide removal. You might even say, oh, it'll be so much better and cheaper by then, why should I do it now? Then that's clearly not right at all. As I say, technologies for direct air capture being developed, they'll set the cost for net zero and for net negative. We've got major plans for CCS deployments in the next decade in a number of countries, including the UK. The UK is hoping to have at least 2 major networks capturing CO2 fairly soon, one on the East Coast, one on the West Coast around Liverpool. But CCS and everything else needs to expand fast and to be successful, because, as I say, the fundamental thing is fossil fuel has to decrease rapidly, and to the extent it doesn't decrease rapidly, it has to be done with carbon capture and storage. The problem is getting CO2 added to the atmosphere. So this is something I saw at the only COP I've been to, which was COP24 in Poland, which I think was pretty civilized compared to the what I've been seeing of the later ones. And this is an advert from the Global CCS Institute, which of course you would expect to support CCS. And there's a young polar explorer with the line, "We must pursue carbon capture and storage like our lives depend on it," because they do. And I think actually, particularly, as I say, having a way that can avoid catastrophic climate change and the consequences of it, which is a combination of carbon dioxide removal, and I think also solar radiation management. I think that's really important, so that people can actually see a way through global cooperation, rather than just having to cope with an inevitable loss in population. Thank you. I'm stopping there.
Thank you. Thanks a lot for this presentation. Really interesting to hear about the different technologies, but also really appreciate how you sort of put it in context of certain equity issues, but also the fact that COP26 was the first COP to be much more explicit about the role of carbon. And yeah, and I think also really mentioning some of the potential limitations of the technology. So I'm sure there'll be questions, and just yeah, everybody, you've got options either to raise your hand via the raise your hand button, then I'll call on you and you can unmute yourself and ask your question, or you can pop your question into the chat, and that's particularly good if you don't want to be recorded. So there's been a question from Sarah. Is there a way to pull other greenhouse gases, e.g. methane, from the air? Obviously methane, very potent emissions. So could you say a bit about that?
Yeah, and there's also the point, essentially the same point from Guwai about addressing greenhouse gases from animal agriculture, which are, well, I mean, all agriculture actually, you're basically getting methane from various forms of land use and from ruminants, but also you're getting N2O from fertilizer use, and that's a very potent greenhouse gas as well. And if you have a look, N2O, it's pretty large. So yes, I don't think there is really a way of getting large scale methane destruction, but there's a lot of calculations about what's called the global warming potential for methane, and it depends on the time scale you're looking at, because methane oxidizes in the atmosphere, and in the long run a molecule of methane has the same effect as a molecule of CO2, really, in the long run, the very long run. But over the first 10-20 years, the methane will trap more heat. And so there's a lot of debate about what the appropriate weighting between carbon dioxide and methane is. I should say also hydrogen does the same thing. Hydrogen's got a noticeable global warming potential, maybe even leaks more than methane. So the thought is at the moment, not that you would try and do something about methane, except in a few places where you can oxidize it, but you can't do that with the whole atmosphere. But that you would do carbon dioxide removal to compensate for the methane. And that means you might have to do 30 times as much, take 30 CO2 molecules out the air, or 30 kilograms of CO2 to get the same effect as 1 kilogram of methane. And that's, that, if you like, that's factored in to some of the equations. I mean, a way to look at it, if you want to think about this, is say you want to have a kilogram of beef, and a kilogram of beef, I don't know what emissions are. That depends on various things, but say it's 10 kilograms of CO2 or even more. Then it might cost you, I don't think it will be that much in the long run. It might cost you as much as £500 to take a ton of CO2 out of the atmosphere and permanently store it. But that comes down to 50 pence a kilogram. So for your kilogram of beef, you've got to pay an extra £5 if you want to negate the effect of 10 kilograms of CO2 and pro rata. On fuel, petrol and diesel, it's even more interesting. A litre of fuel will emit 2.25 kilograms of CO2. So at 50 pence a kilogram, that's adding an extra £1 and a bit to the price of a litre of fuel. Everybody goes, oh, shock horror, we couldn't do that. Well, we've done it. We've paid it to Putin, basically, nearly that much. So it's clearly a manageable number. And as I say, you'd hope to do it for a bit less money. But in a sense, it doesn't matter whether it's a lot or a little. I mean, if the argument goes, look, you're doing something, you don't need to do it. And if you're rich enough to pay to do whatever you're doing, running central heating, for example, when you could just be wearing some clothes, then you're rich enough to pay for the CO2. And if you're not, you're a cheapskate. And if it's a small amount of money, then you're a real cheapskate. And if it's expensive, then you're a real scumbag, because you're leaving this expensive legacy for people in the future. So just do it. And people talk about, oh, let's have a price on carbon. Let's have a price on carbon. What do they mean? So economists say the price on carbon is the damage it causes. But how do you pay that money and actually correct the damage? There is no mechanism. It's just, you just give it to a government. Essentially you're paying somebody to say prayers for your absolution. It's an indulgence. Whereas if you pay to take the CO2 out of the atmosphere and the other greenhouse gases, then you're really negating it. Well, actually, that really has pretty much sorted out the effect. And if you do 10% more, then you're putting any correction for error. So I think actually when we get direct air capture going, it'll be quite different in the way it changes the debate, because it is essentially a matter of money at that point.
Thank you. That's a really interesting perspective. And although I don't think we will have many beef eaters among us here, because I think mostly vegetarians, I guess the carbon footprint of chocolate or coffee is also much.
Coffee is pretty high as
well. Yeah. Anyway, Joe, you've got your hand up, so I'll go to you next, and after that, to Shanti Garba's question in the chat. If you want to unmute yourself, please.
Yeah, thank you, and thank you for the presentation. Very interesting, helpful. I guess this is slightly unfair of a question, but just interested in your reflections. Which is, as far as I'm aware, carbon capture and storage at the moment is being used as a reason to do nothing, right? We'll do it in the future. It's available. So we don't really have to think seriously about reducing emissions. When you say it gives hope, it sort of gives hope, but it also gives a good excuse to fossil fuel companies and so forth to do not very much. That, you know, in the future this will be done, and it concerns me that you know, they continue to emit with the assumption that sometime in the future, you know, it's going to be taken out of the atmosphere. So I suppose if I was to ask you a question, or a more reasonable question, it would be something like, do you think that these plants will actually happen at some point and do the job that they potentially, seem to be saying, could do? And if that's the case, as a little extra, could we just continue to emit then? Is that what you're saying, right? That we just continue to emit carbon, we don't have to reduce it. But I guess my main question is, do you think that these plants will be built at some point? Because at the moment they seem to be a kind of a future aspiration, which is giving reason to do not very much.
Well, so I think I made it clear. I don't think you can emit. Okay, that's not negotiable. And you've got to keep the budget to a reasonable level, and to the extent that you haven't done and you're trying to correct it, you probably do want to manage the temperature. So they can't be an excuse. Well, there's no excuse you can give the climate. The climate will do what it does, and the science is pretty well sorted out. What the excuse is, if there is one, is not to stop using fossil fuel. But it's only an excuse that's valid to the extent that you use fossil fuel without putting CO2 into the atmosphere. People I know in oil companies actually at the moment are being held back by implementing, well, people are being held back by implementing CCS by a couple of things. The first thing that stopped CCS happening basically was that, and I think it came from James Hansen, climate scientist in the US. He demonized coal and sanctified oil and gas. And so the UK, instead of worrying about CO2 emissions per se, stopped burning coal. And a lot of places have done that. And they just carry on burning gas. And so we've had this whole system, which may also have been supported by oil and gas companies. I think it probably was, so, you know, some examples. But it was very much supported by the environmental movement following James Hansen, is that you were okay to burn oil and gas, but you weren't okay to burn coal. And that actually stopped CCS on coal. We've now got a similar thing happening where oil companies are considering CCS and oil and gas, but actually they're worried that they won't get the credit for doing the CCS, that they'll still be in just the same position of being attacked for it. And I have to say, the fact that Saudi tried to get carbon capture and storage talked about at the last COP, and it wasn't even considered. People say just stop using fossil fuel. Okay, fine, but don't expect people to be very enthusiastic about CCS if they don't think they'll get any credit for it. As regards this thing about we'll pull it out the atmosphere in the future, I mean, clearly I think that's about as wicked as it could be. But the best way to get there, I believe, is to get to the point, which we're getting close to, I hope, where you can pull carbon dioxide out of the atmosphere for a cost. And the cost might be, I mean, at the moment, people are talking about $1,000 a ton for these small plants like the one I showed you in Iceland. But it doesn't matter. It's just say you pull CO2 out of the atmosphere and you can do as much of it essentially as you want to pay for. And I think that really changes the debate because, as I say, you don't really have an excuse to not pull CO2 out of the atmosphere for most things you're doing. You know, by and large, most of the CO2 emissions in the world are coming from rich people who could afford that. And if it's costing a lot, then you shouldn't be leaving it for future people. So, but it's got to happen. You know, you talking about CCS is an excuse for nothing. You've got to do it, and you've got to make it work. But once it works, particularly direct air capture, as I say, I think it will be quite transformative because for the first time, it puts a real price on emitting CO2. And you can't just say, oh, I'm doing my best, but I've got to emit some. So you're not doing your best, just sort it out.
Thank you.
Thank you. Thanks. A really interesting perspective also about like not giving companies credit who are starting to look into the carbon capture and removal. So yeah, so there's still a number of questions. So there was Shantika's question around like, what do you say to people who still don't believe the climate science? Then I know Silashiri, you've got your hand up, and then we've got another question in the chat: how energy efficient it is to first use fossil fuels and then store the CO2 back in the ground, compared to directly using renewables or just less consummation and more contentment. Well, I think that question partly answers itself, but anyway. Siri, do you briefly want to ask your question, and then I leave it up to Jon to round up with like all these 3 questions in whichever way you want to answer them to close off the session. Siri, if you want to unmute yourself.
Sure, thank you. Try to keep it brief. I live in Louisiana, which has been identified as a location in the US where they plan to do this carbon capturing into rock. And it's kind of fitting because we are an oil and gas, centrality in the US. And I recognize that the oil and gas industry has trashed our soil, water. It's causing extreme coastal erosion. And so my question is, what is the possibility of seepage, just as we have seepage of oil and gas into our soil and water? We're in a very sensitive area for extreme hurricanes. We lose so much land every few minutes. And so I'm curious what the effects are of, what the possibility of seepage and what the effects are, especially to the oceans.
I mean, the answer is very, very low. The lot of the oil and gas it's not, I mean, there's a few places where you get seepage from geological storage, but most of it is oil and gas that's been produced. I think some of the storage in that part of the world, I don't know about Louisiana, will be offshore anyway, so it won't actually be where people are. If it does come up, you've got extensive offshore storage. And then finally, I'm having a lot of conversations with people involved in promoting this in the administration about environmental justice, and there's certainly a lot of thought that the facilities where CO2 is captured, there'll be a lot of attention to environmental emissions, and that I think is interesting. It's it's where the people looking at the policy on CCS are operating. So I don't think it'll. I mean, it won't be a panacea. You'll need to change things over a period of time. But I think by and large it'll make things better. And then the coastal erosion isn't, that's a function of warming, and it's part. I think it will be part of the way that we avoid warming and avoid dangerous sea level rise. But as I say, I think actually now almost certainly, if you want to keep some of the low-lying parts, and I don't know so much about Louisiana, but Florida obviously is, you can't do anything to stop the water rising because of the porosity of the land. I think your only bet probably will be solar radiation management. I don't think anything else is going to be quick enough now. And that will be an interesting question for people in these low-lying areas. What do they think about that? It's just the reality of the way things are, unfortunately. What do I say about people who don't think the science is sorted on climate? Well, I'm glad. I doubt you were going to do anything useful, and you might as well live in blissful ignorance. If you want to argue with people who actually want to sort out the problem, well, okay, we'll have an argument. There was something else, wasn't there? Oh, the efficiency. Is it energy efficient yet? It doesn't really come into it. It's not. I mean, it's not energy efficient to stuff CO2 down a hole in the ground for the sake of the climate. It's just what you do. Overall, as I said, the question going back to this is low carbon energy systems. And at the moment, I don't think we can run systems that deliver things that people want, which is partly a consistent energy supply, but it's partly also having fun, which is what we use most energy for, or having luxuries. I don't think we can do that without fossil fuels and some other things that we do. So it's not really a question of efficiency. As I say, most things people use energy for are a total waste of money. You know, if you wanted to save money, as I say, you'd wear clothes, you wouldn't have central heating, you wouldn't travel to places. There's loads of things you do that you don't need to do. You wouldn't eat most of the food you eat, even you know, vegetarians. You just live a very different life, but you spend money because you want to. And all I'm saying is that's fine. I don't mind people doing that, basically, but don't put CO2 in the atmosphere. Or if you do, take it out again. That's, to me, that's equivalent. And as I say, I think in the big scale of the planet, I would rather see people use fossil fuels with CCS than use renewables and assume that they're going to leave fossil fuel in the ground as a result. Because I think it's very, very difficult in the long run, and we're talking about 10,000 years, to say how that fossil fuel will be kept in the ground. Same as it's difficult to say, oh, I've got a tree. How am I going to keep that tree from turning into carbon dioxide? Whereas if you've used the fossil fuel with CO2, or you turn the tree into CO2 and put CO2 deep underground, we know from the geology that it will stop there. That's the hard reality. You know, we're not in a, the climate doesn't care. Climate doesn't care whether you know, what your motivations, what your morals, anything. All it cares about is how much CO2 goes in the atmosphere. That's the reality.
Thank you. Thanks. Just aware we're slightly over time. Really, yeah, thanks a lot for being brave enough to, yeah, not just talk to a complete lay audience, but also, yeah, respond to our questions. And I think this last point that you made around like what we're actually using all this energy for, and that it's mostly for fun or things that are from a certain viewpoint not entirely necessary. I think that does really strike a chord, particularly with us Buddhists, around like living a simple life and that sort of thing. So yeah, thanks for that challenge, and thanks for your perspective. Really, really appreciated.